All right, so we're going to be analyzing our data here a little bit that you did yesterday for your virtual lab. We're going to create some graphs out of this data. Google Sheets makes this very, very easy for you, and it can actually predict what type of graph you want to make. So the first thing I need you to do is highlight the data we're going to be working with. The first set of data that we need is the altitude. So the easiest way to do this is to just take your mouse, click on the 0, and drag down to the 400, and then let go of your mouse. And it should leave that whole column highlighted for you. This next part is a little tricky. It's going to require both of your hands. Okay? While holding down the control key, you're going to highlight the density column, starting at 100, going down to that really crazy small decimal number, and then let go. And that should leave both of those columns highlighted for you. We are telling Google what data we want it to use to make our graph. I'm going to do it one more time. You ready? Click on the 0, drag down to the 400, let go. Hold down the control button and do the same thing for the density column, and then let go of everything. Once you've got your two columns highlighted, we're going to go up to the Insert menu and click on the word Chart. So click on Insert at the top of your screen, and then click Chart. And you're going to see it pop a graph right into your document. Somewhere. Where'd mine go? There it is. Took some time. Now, the last thing we need to do, if you already closed it like I did, we need to get our chart options back up here. There should be 3 little dots in the right-hand corner of your graph. Click that and click Edit Chart. And it should pop that window back open. I closed mine accidentally. There's one button I would like you to push in here. It's this Aggregate button. It's got a little checkbox next to it. When you do that, you'll see your graph got a little longer. So what the Aggregate button does, instead of using increments of 100, now they're using the increments that were in my data table. 0, 5, 10, 25, so on. Just makes the graph a little easier to visualize. So this is a graph of density versus altitude. Okay, altitudes are x-axis along the bottom, densities are y-axis along the side. What this graph tells us, as we go up in altitude, density goes down. What is altitude? What does that even mean? Yeah, how high above the ground you are, right? So if I am at 0 altitude, that means I'm standing on the surface of the earth. And then we go up from there. Your measurements for 5 kilometers, 10 kilometers, 25, so on and so forth. The higher you went in the atmosphere with your weather balloons and your rockets, the lower and lower and lower the density became, until eventually it was 0 for most of it, right? What is density? What does density mean? What's density mean? Density. Oh yeah, look at that. Way to use your resources, man. So proud of you. I said I was proud of you. Density is a measurement of how close together particles are. So if we have 2 atoms that are really close together, we say they're dense. If we have atoms that are far apart, we say they're not dense. Does that make sense? In terms of the atmosphere, when we get our nitrogen and our oxygen molecules are all packed close together, that's really dense air. When they're far apart, It's not dense air. So the higher we go in the atmosphere, the less dense the air is, which means way up here, the particles are spread apart. Way down here at the ground, the particles are packed together. Make sense? All right. What I want you to do is drag this graph down and off to the side, just so it's out of the way of your chart. Don't delete it. And we're going to do the exact same process, but with some different data. So this time we're going to use still the altitude. So go ahead and highlight the altitude numbers. While holding down Control, we're going to get the pressure numbers. And now you should see those two columns highlighted. Go to Insert, Chart, and it should pop up too. And then click that Aggregate button again. You should notice that this graph looks very similar. What's pressure mean?
Pressure means like, that is what you think, but in science, it's like pressure against something.
It's a force pushing on something. Okay? Air pressure is the force of air pushing down. This graph looks really similar. It says, as we go higher in the atmosphere, the air pressure goes down. Right? That makes sense. Because if I'm down here at the ground, there's a lot of air up above me. And all that air is pushing, 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 pushing. But if I'm way up here in the atmosphere, what's up above me? Nothing. Outer space. And what's in outer space? Nothing. It's a vacuum. Think of it this way. Let's imagine we're going to make like a human pyramid. But instead of making a pyramid, we just stack people straight up in a line. Person on top of person, on top of person, on top of person, on top of person. What's it going to be like for the person on the bottom? They're going to be squished. What about the person on top? They're fine, right? Atmosphere works the same way. If you're down here at the bottom of the atmosphere where we are, there's a lot of air pushing down. So we have a high air pressure down here. Way up here in the top of the atmosphere, there's nothing pushing down. There's no air pressure. Okay? Take that graph and slide it down and out of the way. And the last graph we're going to make will follow the same process, but with temperature. So highlight your altitude data, hold Control, highlight temperature. Insert chart. And once again, you can hit that Aggregate button. Now, this graph is a little misleading because the scale of the temperature is really big. Here on Earth, our temperatures probably reach like maybe 50 degrees Celsius down to maybe negative 30 degrees Celsius. So 1,250, that's crazy hot. So the scale looks really funny because it gets hot up in the upper atmosphere, which we'll talk about here in a second. Now, the graph says at ground level, it's pretty warm. You know, average temperature, 20 degrees Celsius. Nice. As we start to go higher in the atmosphere, it gets colder, 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 colder. And then all of a sudden we get this little spike here, right about 50 kilometers above Earth's surface. What's happening to make it get warmer? What's there? Something really special right about that 50-kilometer mark. Why would it get warmer? Karis, what do you think? The ozone layer's there, absolutely. And what did we say the ozone layer does? Absorbs energy. What happens when things absorb energy? They get hot. So even though the higher you go, the colder it gets, at some point that's not true because the ozone absorbs a lot of energy and makes it hotter there. All right, then we keep going higher and oh, it gets cold, 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 cold. Whoa! It got hot. Why? Why? Not necessarily closer, because closer to the sun from 200 kilometers to 0 kilometers, closer to the sun would be like this for me and you. I got closer to you. Did I really get closer to you? Not really. But it is the outer layer, which means it's absorbing a lot of energy, right? It's the first line of defense. All those UV rays, the light, there's some X-rays even coming from the sun, they get absorbed by this layer. And because this layer is absorbing a bunch of the heat, by the time the sun's light gets to us down here, it's not nearly as hot as it could be. This is one of those things that helps keep Earth's temperature moderated. It doesn't get too hot, doesn't get too cold, because the atmosphere has helped filtering out some of that energy.